Hello everyone! I'd like to introduce a breakthrough technology we call the train vacuum envelope operation technology. It would be possible to solve the technical problems that Hyperloop is facing and help to make Hyperloop a reality very soon. This system can reach the same operation efficiency as Hyperloop at over 1,000 kilometers per hour. It has a very different setup. Unlike Hyperloop, it does not need to vacuum the tube system and uses an open tube as the running track, and has the train body enveloped by a vacuum in motion and travels at high speed in the open tube. Our current high-speed rail cannot reach airspeed because of many unsolved technical problems. Some of these problems include derail risks and running resistance. Elon Musk has taken the first step to reach this goal through Hyperloop. Its core technology includes the sealed tube, the vacuumed full tubing system, magnetic levitation, and axial compressor. The Hyperloop has not been made a reality yet and is still trying to overcome technical problems. Our train vacuum envelope operation technology is different from Hyperloop. Our core technology includes the open tube, the vacuum enveloped train, and magnetic levitation. When we compare our technology with Hyperloop, we can see for the rail, Hyperloop uses a completely sealed tube while we use an open tube. For the vacuum, Hyperloop has a full tube vacuum, while our train is only surrounded by the vacuum while it is in motion, and the rest area in the tube is in normal pressure. Levitation and speed is the same, both are magnetic levitation and sound speed. Our system is completely different to that of any other ground transportation and surpasses the high-speed rail and magnetic levitation. The core technology of this newly developed innovation is called the train vacuum envelope operation technology, which is a revolutionary achievement and shall become one of the leading forms of transportation in the world in the future. This is the structure diagram. The major components of this technology include the running tube, head, front blocker, passenger car, vacuum space, rear part, rear blocker, and turbofan. The set of airflow blockers in the front and rear block air leaking into the vacuum space. At the same time, a high-powered turbofan engine in the rear parts of the train intakes air from the vacuum space and expels it outside to maintain the low pressure of 30 kilopascals or below. This is an animated video of the blocking structure. You can see the front blockers, vacuum space, and the rear blocker, and vacuum, of course. When we analyze the operational principle, we can see a high-speed train is around 200 meters in length. When a train is running at super high speed, over 95% of the running resistance is from air resistance, of which the pressure resistance from the head is 5 to 8%, and the airflow resistance from the body is more than 90%. The action site of this technology is to reduce the airflow resistance from the body, and such reduction by this technology can be low as 80%. So the airflow resistance from the body can be down to 20% or less. Combined with the pressure resistance, the total air resistance reduction should be by 70% or more. Another important issue that must be solved is the accumulated high air pressure in front of the head. This technology designs multiple one-way airflow windows on the wall on the running tube. When the train moves forward, the air pressure in front rises, and the one-way airflow windows open passively, balancing the air pressure in the front with the air pressure outside the tube so that the pressure resistance in the front of the head remains unchanged. We have done a lot of studies and trials in regards to this technology. The small-scale test results show that this technology is feasible and can form the local vacuum enveloped state of the train. We have done two kinds of experiments, one in motion and one in still. For our in-motion test, we prepared a 200-meter stainless steel tube and then started the engine at 60 kilometers and saw the pressure decrease by 8.2 kilopascals surrounding the body of the running device. But the tube immediately collapsed and further ruptured. That is because our testing tube was not strong enough to resist the low pressure formed inside. For our no-motion trial, we tested it in a still state in a much stronger tube. After we started the turbofan engine, the air pressure surrounding the running device was decreased by 32 kilopascals. This is an animated video of this technology. We can see start. Drive into the tube. Locking system operates to create the vacuum state surrounding the train body. Front one-way airflow window operates passively to release the high air pressure in the front. Rear one-way airflow window operates actively to remove the low pressure state in the rear. The train accelerates to 10 times the speed of a car. The window is sealed to prevent air from leaking. This is the construction and extension of the tube. This is a comparison of the front and rear blocking space. Turbofan engine intakes air from the vacuum space and expels it outside to maintain the low pressure of the vacuum space. The train travels at airspeed These are the passengers during an emergency evacuation. Crossing the tunnel, approaching the station, actively closing up the front one-way airflow window to increase the air pressure resistance and slow down the train, withdrawing the blocking system, and finally arriving at the station. Our technology is able to solve the technical challenges that Hyperloop is facing. I'd like to present that in several aspects to give a better understanding of our technology. The first one is the establishment of the running tube. Hyperloop uses a full vacuum tube and a sealed tube. It is very difficult to accomplish using current technology. Our system uses a normal pressure tube and an open tube, and can be established by current technology. The second is airspeed. Hyperloop is designed to travel at sound speed. 1,200 kilometers per hour, but must rely on the completely sealed, low pressure, and very long distance running tube. This has not yet been made a reality. For our envelope system, train is enveloped by vacuum utilizing magnetic levitation and linear motion driving, and is accomplishable by current technology. Systematic risk due to huge energy accumulation. Hyperloop. There is a huge energy accumulation in the sealed and low pressure tube. Energy accumulation in the 1,000 kilometer tube would be close to a small atomic bomb. Envelope. Since we use an open tube, there is no energy accumulation and no systematic risk. Thermal expansion. Hyperloop. It is very difficult to solve the issue of thermal expansion during its construction because movable joints on such huge energy accumulated tube would be very risky. Envelope. Again, open tube, no energy accumulation, no such risk. Emergency evacuation. Hyperloop. Emergency evacuation is difficult to set up in such completely sealed, low-pressure tube. Envelope. Once again, open tube. So very easy to set up emergency evacuations. Passenger would simply open the door on the car, open the door on tube, and exit. Passenger capacity. Hyperloop. 30 passengers. Envelope. 1,200 passengers, same as the high-speed train. Construction. This technology is also very cost-friendly. The current high-speed rail needs a very strong roadbed in order to ensure safety, which costs a lot of money. This technology does not need such a strong roadbed, so its costs of construction are not as high. Our main focus is the open tubing system. With this technology, we can reduce the cost of construction to 50% less than the existing high-speed rail. Patent protection. This technology is under full patent protection. It has 8 Chinese patents, 2 international PCT, 2 US patents, 2 EU patents, and 2 Japanese patents so far. These are some of our patents or pending patents. This is our plan. As of the moment, we need to complete a large-scale test with an 8-kilometer experimental tube at 1,000 kilometers per hour and finish more condition testing regarding driving, braking, control, and blocking. We are looking for the support and collaboration from the people who are interested in this technology, especially Hyperloop. We believe this breakthrough technology is vital to making Hyperloop a reality very soon. Dr. Marvin Liu is the inventor of this technology. He is a very great inventor and technologist. His unconventional, cross-disciplinary, and creative thinking is his most specialized characteristic. He has completed many inventions, and some of them have proved to be a breakthrough by marketing application. Thanks for watching!